Hi everyone, it's Professor Monty, and we are going to find the terms of a geometric sequence. So this says find the first four terms and the 14th term of the geometric sequence with first term a sub 1 equals 2 and common ratio r equals 3. Remember, with the geometric sequence, we multiply by the common ratio to get the next term. So it already says a sub 1 equals 2, and just put that in there. Well, the next one is obviously going to be times 3. That's the common ratio. So I'm just going to go times 3. Well, 2 times 3 is 6. And then we multiply that by 3 to get the next one. So 18. We multiply that by 3 to get the next one. 54. And that's the first four terms. And I'm going to use this idea. If you saw my video like this on arithmetic sequences, I'm going to do something similar to show you where the general form comes from so we can get the 14th term. All right, here's the idea. So what I'm going to do here, let's go ahead and erase this real quick. We already have this as our answer. So if we wanted to just box that, we could. If we wanted to list them, 2, 6, 18, 54, we could do it that way. That's my first four terms. But let's see how this worked. So we started obviously with the 2, but then we did 2 times 3, the common ratio. And then we did 2 times 3, and then again another times 3, and then another times 3. So we started with that, and then we said, oh, and then multiply by 3 to get our numbers. So let's use this to find a general term. And in general, with a geometric sequence, what happens is this. We always start off with my first term. Well, my first term here, we just call it a sub 1. So we started with that term by a sub 1, and then I multiplied by the common ratio. But the key is how many times did I multiply? Notice on a sub 2, my second term, I only multiplied once. On a sub 3, I only multiplied twice. And a sub 4, I only multiplied 3 times. So it's one less than what I had before. Well, to show multiplication, what I'm going to do is I'm going to say, okay, it's this a times 1 times my common ratio. And I can do that times more r's as I go, but usually what we do for repeated multiplication, we show that as exponents. That's what exponents mean. And so what I'm going to do, instead of saying that, I'm going to say, okay, how many times am I multiplying by that common ratio? Well, whatever the n is, whatever term it is, that's my n. So when it was 4, I did it 3 times. When it was 3, I did it 2 times. So it's 1 less than n, so I just go n minus 1. And that's what we call the general term of a geometric sequence. And then what I do for the 14th term, if I want to find a sub 14, I said, oh, it's a sub 1, that's a 2, times the common ratio, 3. How many times? Oh, 14 minus 1. Or 2 times 3 to the 13th power. That's going to be a big number. Remember, you do exponents before you do multiplication. In the computer or in the calculator, you can just type in 2 times 3 to the 13th power. And the power usually looks like x to the y or y to the x or a little exponent like that. Those are usually your buttons for exponents. But calculators know order of operations. So you can just take 2 times 3 to the 13th power. And that's what I'm going to do right here. I've got my calculator handy. 2 times 3 raised to the power 13 equals, and I get 3,188,646. And that was my 14th term. So hopefully that helped out. These numbers grow quickly, especially if your common ratio is bigger than 1. If it's smaller than 1, if it's between 0 and 1, it actually shrinks. And then if it's negative, it goes into the negative zone. Actually, if you have a negative ratio, notice when you raise that to an even power, it becomes positive. So it oscillates, it flip-flops back between positive and negative numbers. All right. Anyway, hopefully that helped you out. Work with these. You'll get them. It's not that big of a deal. It just takes a little practice, just like anything else in math. But remember, you can do it. And keep going. I'll make some more videos. Hopefully that'll help you out. All right. Have a good day.